Hello everyone, welcome back to my YouTube channel. Today we are going to see class 10 science 2 chapter number 5 towards green energy. When we talk about the word energy, it's nothing but the capacity to do the work. Whenever we want to carry out any task or any work, whether it is a small or big work, doesn't matter, like movement of your thumb or the finger of your hand, or lifting a bag or the weight of 100 kg. One is a very small and the one is very large amount of energy is needed. Means the energy decides, or it gives an idea about the capacity of a particular person, machine, or anything, what the work it can carry out. Energy and use of energy. When we talk about this particular word, this what they have given is nothing but what, that our daily life is incomplete without energy. Energy, the different forms they have given over here, the different kind of energy which we are using in our day-to-day life, that is the mechanical energy, chemical energy, sound energy, light energy, heat energy, different kind of forms of the energy we are using in our day-to-day life. And this energy, when we talk about, is nothing but decides our life. How? That we will see as we will progress in this particular chapter. We will come to know about this particular words, what exactly it means. First, what we have to study over here is the generation of electrical energy. Most of electrical power plants are based on a principle of electromagnetic induction invented by Michael Faraday. About this electromagnetic induction, we are going to learn in a science 1 in a detail. So that particular concept, or that particular principle of given by the Mr. Michael Faraday in a electromagnetic induction, that we are using in this particular part of the energy, that is the generation of electrical energy. What it says actually, a field or the field around a conductor can be changed in two ways. If a conductor is stationary and magnet is rotating, or conductor changes, or if a magnet is stationary but the conductor is moving. Means, in a simple words, if I want to talk about, if there is a change in a magnetic field and a coil is placed in that magnetic field which is continuously changing, then the current will be induced in a coil. So same concept we are using in this particular section, in this particular generation of electricity. When we talk about, this concept is used. For that, they have given over here the picture. You can see over here, this particular section, the magnet is placed and the magnet is rotating continuously. You can see there the axle is there and it's rotating continuously. So here there is a rotation of the magnet continuously, so that changes the magnetic field continuously, and the coil is placed in that magnetic field. So once the magnet starts to rotate or to change the magnetic field continuously, it induces the electric current, which we can check it out with a voltmeter or the galvanometer. Now here in this particular section, when we talk about, this is a simple concept which is used in most of the electrical generation or the generator power plants. You can see here they have shown one example they have taken of the turbine, steam turbine. So here there is a nozzle which applies force with the help of the high velocity steam, water, whatever we are using in this particular section. So once that turbine starts to rotate, this is called as a turbine, this starts to rotate, that rotates this magnet continuously, and that produces the current which we call as the electricity. Now further, you can see the other view also they have shown over here. You can see there is a coil and the magnets. So these magnets which is rotating continuously is changing the magnetic flux or the magnetic field, and due to that, this generates the current. You can see over here the proper energy source to run turbine. Then the turbine rotates, generator generates electricity or the electrical energy. Now the next what we have to see is a or thermal energy based electric power station. In this, what exactly we are doing? We are using a fuel as a coal over here. The coal is used to produce heat, and with the help of that heat, water is boiled, boiler for conversion of a water into steam, and that steam passed over the turbine to rotate the turbine. The current of a steam is used to rotate a turbine, and once that starts to rotate, that rotates the generator magnets, and that produce the electrical energy. And at the same time, when the steam is passed over the turbine, it's recollected, condensed, and convert back into the water, and again that water will be heated and converted into steam. Means the cycling of water goes on continuously, and along with that the current of a steam is used to move the turbine. So that they have shown over here with another picture over here. You can see what exactly we have here. Fuel or the air boiler is used over here, which boils the water, then it passes through the pump, and the current of water you can see over here, and that rotates the turbine. Okay, now the further is another they have given over here is the chemical energy in coal, then the thermal energy, kinetic energy in the steam, kinetic energy in the turbine, and then the electrical energy. You can see the transformation of the energy from the chemical energy to the thermal, thermal to the kinetic, kinetic to the electrical energy. So change in the forms of electrical, in the different forms of the energy. Now the problem with this kind of the power plants, problem is the air pollution, because if any fuel is used, here they have talked about the coal, I'm talking about all the different kind of fuels which is used in our power plants, whether it is a nuclear, whether it is the coal or the some other fuels, it creates or it causes the air pollution. So they have given over here the air pollution due to burning of coal results in emission of gases like carbon dioxide, sulfur oxide, and nitrogen oxide, which are harmful to the health. Along with the emission of gases due to burning of coal, soot particles are also released into the environment. This may cause serious health problems related to the respiratory system. The reserves of fuels used in this method, that is coal, are limited. Therefore, in future, there will be limitation on the availability of the coal. So here in this particular section, what are different kind of the sources of energy or the fuels are used in this case are having a limited availability, and due to that in a future this kind of power plants are not going to work with a full capacity. Another some more information they have given is about the thermal power plants in India. One is at the Vindhya Nagar, Madhya Pradesh. The capacity is a 4,760, one of the biggest thermal power plants we are having in country. Then the Mundra in Gujarat is having a two power plants, 4,620, and the another is a 4,000. Then we have the Tamil Nadu in the Chhattisgarh, which is having a 3,400, and then the Chandrapur Maharashtra, that is 3,340 megawatts. So these are the capacity, how much they are producing energy. Next, power plant based on nuclear energy. The basic concept is the same. Here, instead of a fuel as a coal, we are using the nuclear energy, and that same the energy or the heat produced by the nuclear reactions that is used to boil the water again. Then the water will be passed over the turbines in the form of steam, and then the water will be recollected, and that rotating turbine will produce a, or that rotates the magnet, and that produces the electrical energy. That concept is same, only the beginning is a different. That is, instead of a coal we are using the nuclear energy. That's it. Further is nuclear energy, then the thermal energy, kinetic energy in turbine, and then the electrical energy. The concept is same. Here the neutron is bombarded on an atom of a uranium 235, and that 235, it absorbs the neutron and converts into an isotope uranium 236. Uranium 236, being extremely unstable, converts into atoms of barium and krypton through a process of a fission, releasing three neutrons. So here what happened? A single uranium 235, when it is bombarded by the neutron, it absorbs and forms a uranium 236, which is highly unstable. It's radioactive. So it breaks down into a barium, krypton, and along with that, three new neutron comes. So that three new neutrons can strike a uranium 235. Three different uranium 235 means with a one neutron, you can see here in the picture they have shown this one neutron, when it's striking the uranium, it's making a 236 and then producing a barium, then the krypton, and the three new neutrons. So these three new neutrons can strike three different uranium 235. And in this particular process of breaking or the nuclear fission, 200 mega electron volt energy is liberated. So that energy what it's producing will increase drastically. So these neutrons which are generated in the process of a nuclear fission, they should be absorbed at a proper level. If not, then that may lead towards the explosion of the entire power plant. Further, when we talk about on the other side, they have given some information regarding the other nuclear power plants in our country. So we will just see the one they have given as a Kundakulam, which is in a Tamil Nadu. This one is in a Tamil Nadu, and the capacity for this as a 2000 megawatts. Next, they have given as a Tarapur. This is in Maharashtra, and the capacity for this as a 1400 megawatts. Next, they have given as a Rawatbata. It is in Rajasthan, and the capacity for this as a 1180 megawatts. Next is a Kaiga. It is in Karnataka. I'm writing in a short, you can write in a full form. This is in a Karnataka, and the capacity for this as a 880 megawatts. So these are the important nuclear power plants which we have in our country. Now the next they have shown over here is about how actually the nuclear power plants works. In this also, the same concept we have the nuclear reactor. You can see here the nuclear reactor which produces energy or the heat, and the water is boiled in it. Water is boiled, so from here the steam comes which rotates the turbine. Turbine is connected to the generator, it produces electricity, and that steam is recollected in this, and the cold water is passed continuously. Warm water goes and the cold water comes out, and it's recollected and goes to the pump again. Means the same concept, everything is same, only the beginning is different. That is, instead of using a thermal or the other sources or the fuels, we are using the nuclear energy, and that produces a huge amount of heat. Further, the next problems with this now. Problems are the products after fission of a nuclear fuel are also radioactive and emits harmful radiations. The products are called as nuclear waste. How to dispose the nuclear waste safety is a big challenge before the scientists. And accident in nuclear power plant can be very fatal. This is because the accident may result in release of very harmful radiations. So these are the very problematic issues we have related with this particular kind of power plants. Next, they have given is a power generation plant based on energy of natural gas. Compressor for the pressurized air, then the combustion of chamber or the combustion chamber, then the gas turbine, then it passes over the generator, and then the electrical energy is produced. Arrangement, they have given this in this particular section. Further, here they have given the change of the transformation of energy, that is the chemical energy, natural gas is converted into a kinetic energy generated due to combustion of a natural gas, then the kinetic energy in turbine, and then the electrical energy. The working or the schematic diagram of this kind of a power plant they have given over here. Fuel is used, then the combustion chamber releases the gas that which is used to rotate the turbine, and then that produces the electricity with the help of the generator. Here also they have given the information regarding the different power plants which works on the gas. One is in Samarkota, Andhra Pradesh, producing the 2620 megawatts, and the Anjanwal, Maharashtra, 2220 megawatt, then the Bhavana, Delhi, 1500, then the Kondapalli, Andhra Pradesh, 1466 megawatt. So these are the power plants we have. Then next is electric energy generation and environment. When we talk about this particular section, that is the electric energy generation and environment. Electricity generation based on fossil fuels like coal, natural gas, and nuclear fuels like uranium and the plutonium are not environment friendly. It's very clear because they are producing a different kind of gases or the nuclear waste, which is very harmful to the environment. It means that if electrical energy is generated using these fuels, it can lead to environmental degradation. So, this degradation, when we talk about actually, whenever we are producing any form of energy, especially the electrical energy, then there should not be a waste which is harmful to the environment. It should be clean. We have seen that burning of a fossil fuels like coal and the natural gas leads to emission of a certain gases and soot particles. This results in air pollution. Then the nuclear power plants, when they are producing the waste, it produces the soil pollution, water pollution. So these are the effects, or these are the problems are related with the all this kind of energy power plants. It took millions of years for formation of a fossil fuels like a coal, crude oils, and the natural gases like LPG and CNG. So this particular gases, when we talk about, or this particular fuels, what we talk about, they are in a limited quantity. So their use should be limited. If we are using in a large scale in this particular power plants, then the depletion of this reserves will take place, and that will be another problem. Then next is we have also discussed about the problems in use of nuclear energy. There is a disposable of a nuclear waste and the possibility of a disaster due to accident in nuclear power plants. Considering all these points, it can be said that an energy generation from fossil fuels and nuclear fuels are not environmental friendly. So we should think about some other kind of power generation. So in the next part, we are going to talk about the environment friendly energy generators, and in that we will see what the different possibilities we have for the eco-friendly or the environment friendly energy generators.